So I think, of course, the advantages, as I actually also mentioned shortly before, is that it's a very scalable tool so that we can generate loads and loads of different cells. So, of course, for a big number of transplantations and to really tackle the clinical problems. So it's a very desired tool. For instance, if we compare with transplantation of embryonic tissue, of course, is more limited. We need to coordinate also acquiring the embryonic tissue, transport of the embryonic tissue, therefore also at the end time with the transplantation. So it's logistically it's also very complicated. By using human pluripotent stem cells, we can derive a high number of cells for the specific cell type that we are interested, and that, of course, is much more desirable. But of course, there are also some disadvantages, and these are the things that we are trying to improve in the field. So, for instance, in pluripotent stem cells, we have embryonic stem cells or we have induced pluripotent stem cells. So the use of embryonic stem cells involves the destruction of an embryo, which has legal and ethical consequences and limitations. And of course, starting from embryonic stem cells, you cannot do autologous transplantation. So autologous transplantation meaning using the cells from the same donor for the transplantation of oneself. On the other hand, the use of induced pluripotent stem cells, which are possible thanks to Yamanaka, that they generated and discovered the first limited number of transcription factors that they are necessary to reprogram adult somatic cells into induced pluripotent stem cells. So these cell types are, of course, they don't have that much legal consequences because, of course, they are coming from adult somatic cells. But however, there are other concerns like, for instance, genetic and epigenetic instability that could come from reprogramming strategies. So I think also part of the field is also trying to tackle those and to avoid, integration of factors that they are not desirable also for the final cellular product for transplantation. And I think with both of them, embryonic stem cells and induced pluripotent stem cells, there is also the concern that they could generate tumors. So I think as well to block, the important thing here is to try to generate a product of high quality to ensure the purity of these cells. So we need still to work on different methods to isolate the right cell types. After differentiation from human pluripotent stem cells, we need to look also a bit more into quality for the maturation stage of the cells. For instance, to have a cell type that can generate insulin in the pancreas or a fully mature neuron that can integrate in the brain upon transplantation, for instance, for Parkinson's disease. And also part of the field is now a little bit interested in generating a specific cytoarchitecture. So instead of only transplanting dissociated cells, generating in vitro as well, like a tissue, for instance, for transplanting as well retinal pigment cells from pluripotent stem cells. And I think also a major hurdle right now, it's the immunogenicity of these cells upon transplantation. And this is also what we were talking a little bit, the autologous versus allogenic transplantation. And of course, autologous, it will be more desirable, thinking that this is the same cells that they are transplanted in the same individual. However, this is very costly and is very time consuming to generate a specific cell type for each donor, for each transplantation and the recipient. And of course, if the cells of the donor, they also carry mutations, or if there is a cancer, for instance, that cannot be used as well. So I think on that perspective, allogenic transplantation could be more far-reaching strategy. And in that field, what is actually quite important right now, is that there is a number of researchers that they are trying to find like a number of induced pluripotent stem cells. They could be used in a bank, for instance, generating a number of different cell types that they are HLA matched. So basically that they are going to be more matched to the recipient, and they are not going to raise some immunogenicity after transplantation.